In this video segment, we're going to be covering probability. Now, probability is the likelihood that something's going to happen, and it's usually expressed as a fraction. For instance, if you were rolling a die, maybe 3 times out of 6, or 1 out of 2 times, in other words. Or it could be you're picking marbles out of a bag. And in some cases, you'll be picking those out and putting them back in and maybe trying to pull out another marble. Or sometimes you'll take something out and leave it out and then make another withdrawal. And we need to know what to do in all those different cases. But there's one formula that we can look at, and you've seen this formula before, but it's probably been quite a few years since you did anything with that formula and probability. So it's probably a good thing for us to review it. Now, the good thing is there's not going to be very many probability questions on the SAT. And I believe if you know this formula and you think through any problem they throw at you, you're probably going to be well off. So let's get started. Okay, let's take a look now at the probability formula. The probability formula can be written in several different ways, but the way I like to write it is the probability of X equals the number of X objects divided by the total number of objects. Okay, and let me just give you some quick examples here. Let's say we had red and we had blue marbles. And we had in a bag, we had 30 marbles. And let's say that 10 of them were red and the other 20 were blue. What's the probability that if you reached into that bag and pulled out a marble, that it would be red? Well, you have 10 red objects, and your total number of objects is 30. And of course, this would reduce to 1/3. That's essentially what we're doing. Now, when I say objects, I'm kind of using that in broad terms. It could be numbers or dots on a die, from a pair of dice. And then you would have a total of 6 different dot patterns on those die. And so your total objects would be the dots. There's 6 different possibilities there, and then you would figure out the probability as to the fact that there are 6, and if you're going to roll it one time, then if you were wondering if it would come up at 2, there's only 1 2 on the die, so it would be 2 out of 6, which again would be 1/3. So that's basically all you need to know about probability in order to do anything that you're going to be dealing with on the SAT. So let's take a look now at some examples. Okay, let's take a look now at a typical probability problem. This is a number 3, so it's going to be fairly easy. We've got a jar that contains a number of jelly beans, of which 58 are red, 78 are green, and the rest are blue. Now, if the probability of choosing a blue jelly bean from this jar at random is 1/5, or 1 out of 5, how many blue jelly beans are in the jar? Now, the twist that they gave you here is when I was showing you the formula, you would like to know what the total number of jelly beans are, and then you would find out, and they tell you how many of them are blue, and then you'd find out the probability. But in this one, the hook is they give you the probability, and you've got to figure out how many blue jelly beans you have. So let's use a little logic here. We know that the total has to be 78 green, and it's got to be 58 red. And we know that, well, we don't know that how many blue we have, but we do know that that is the total. So this is going to be your denominator of that probability formula. And your numerator, of course, would be the number of blue marbles you have, okay? And it, of course, is equal to your probability, which is 1/5. When you set it up this way, you see you have cross multiplication. We end up with 5b equals 78 plus 58 plus b. And we subtract b from each side. Get rid of it over here, and it changes 4b over here. And 78 added to 58 is 136. And now we divide both sides by 4, and we get that b equals, 4 goes into 13 3 times, and in 16 4 times. 34 is our answer, so we would circle A. Okay, here we have a probability problem, and it probably looks pretty familiar, as all probability problems look. This is one of those where you got a bunch of stuff in a bag. And this has a number 19, so it's perceived as being possibly difficult. And the only reason I can think that it might have been classified as that is it has one little curve in there that's possibly considered a Joe Boggs trap. And that is, unlike the problems where you take something out at random and you replace it, in this case, I want you to notice, let's read the thing together. A bag contains 4 red hammers, 10 blue hammers, and 6 yellow hammers. If 3 hammers are removed from the bag at random and no hammer is returned, that's the trap I'm thinking, to the bag after removal, what is the probability that all 3 hammers will be blue? The trap is that when you don't return something, the total number of objects in the bag changes, and of course that's going to change the total number of objects as far as a denominator on a fraction that determines the probability. So let's take it one drawing at a time. We're going to draw 3 times, and they want to know what's the probability of it being blue every time. So we start out, when we do the first drawing, we're going to have all the hammers in there. We've got 4 plus 10 plus 6. That's 20 hammers for our denominator. And we've got 10 blues. So the first time we draw, and you can get rid of these zeros, it's a 1 to 2 probability that you're going to get a blue hammer. But you have to be careful. You've removed it now, that blue hammer. So now there's only 9 blue hammers in there, and there's a total of 19 hammers in the bag. Then on the third drawing, since you got a blue hammer on the second drawing, you are going to only have 8 blue hammers left in the bag, and you're going to have a total of 18 hammers in the bag. And this reduces to 2 goes in there, 4 ninths. So let's multiply this out. We've got 1 times 9 times 4, which is 36. And then we've got 2 times 19, which is 38. And 38 times 9, you do this on your calculator, 72, carry your 7, 342. So our numerator is 342. And of course, we can reduce this. If we take 18 into both of those, 18 goes into 36 2 times. And if you do this on your calculator, it goes into 342 19 times. That's dividing both the top and bottom by 18. So your answer would be 2 over 19. Okay, here we have a problem that's a probability problem, and let's just read it together. Tiles numbered 1 through 25 are placed in a bag. If one tile is removed at random, what is the probability that number on the tile is a prime number? Now there's several ways that somebody could mess up on this problem. The first way is to not know what a prime number is. A prime number is a number that can be divided by 1 or itself, but cannot be divided by any other number evenly. So we need to know how many of those prime numbers are in the bag. We know we've got 25 total objects in that bag, but how many of them are prime numbers? So let's just start writing them down. Now, the other part of the trap is a lot of people, when they're putting down prime numbers, they think 1 is a prime number, but it's not. You start with 2. Okay, we've got 2, we've got 3, we've got 5, we've got 7, we've got 11, we've got 13, we've got 17, we've got 19, and we've got 23. And we can't go any further. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9 prime numbers are in that bag. And so it's a simple problem from there. We take the number of objects, which we're trying to figure out what's the probability of that object. So we got 9 prime numbers, and the total number of things that are in the bag is 25. So this is a grid in, and you would grid in 9/25.